Hi everybody, welcome to another video on Python for Linguists, this time about reading files, which will mark a major step forward in terms of putting ourselves in a position to interact with actual realistic language data for the actual purposes we will want them for for linguistic analysis. As always, there will be code examples, there'll be a couple of small exercises, so be ready to code along, to pause the video, at places where you're asked to produce your own code, and enjoy the video. So to preface this, interacting with text data so far, we have done this with a very tedious approach where we highlighted, copy pasted large chunks, entire corpus texts into Python, and then used the strategy of 3 consecutive quote marks to kind of read all of this in as one big string. There are several disadvantages to that. The most obvious is probably that um, it always requires a human doing something mechanic, something very tedious, and something that doesn't scale well, especially when we want to read lots of different text files, maybe. So we'll put ourselves in a position to do that at the end of not this video, but 3 or 4 videos, including this one. So we'll take a bit of time to develop this, but the benefits will be great. And ultimately, this will put us in a position to have corpora, any kind of structure collection of text that typically is available as separate text files, and systematically read those corpora in and do something with them in order to really work with these. In order to do that, just a slight kind of side note on directory structure. In order to meaningfully or effectively work with files on your computer, you need to understand the directory structure, which is sometimes obfuscated by the graphical user interface and symbolic links in our present-day operating systems. But it's really a simple structure. Every file on our computer lives in a directory, and most often that directory is a child of a parent directory or a subdirectory of a parent directory. That very often, again, is the child of a higher level directory. So we have this hierarchical tree-like structure, and we can specify the location of any file on our computer by starting from our base root directory, the highest level directory, and then sort of just follow down the directory path to that file. So for example, in my case, we'd have something like root, which is just the first slash here, home, Axel, documents, and all of these are directories. And then within the documents directory, which is a child of this Axel user directory, uh, within that lives a file called test.py. So if we want to execute that file or read that file in, we need to have access to this whole file path. For the time being, I'm just going to talk about absolute file paths that kind of specify from the top level directory on your computer where to go. It's also possible to work with relative file paths, but I'm going to leave this for another lecture. So this is what you need to know. There's 2 things to note here. The first is if you're unsure what the specific file path, file path in the directory structure looks like to your file, you can always find it in your graphical um, data Explorer, whatever it's called in Windows. Um, Find the file, right click on it, and get something like properties or get info, I think, on a Mac, and it'll specify the path to the file itself. Sometimes omitting the file name, so sometimes you need to reattach that, but it'll give you all the information you need. The second note is slightly more complicated. If we want to work with these in Python, white space in any directory name or the file name itself is just going to be a headache. And I'm simply, for the time being, going to work on the assumption that we're not going to have any white space. There's various and operating system dependent strategies of kind of including or rewriting, escaping white space through the use of special characters when specifying a file path. Otherwise, Python gets confused. will break the code that I just don't want to go into right now. So I'm going to assume there aren't any white spaces in your directory structure. If there are, you can always right click on the directory that has something like my white space pictures. Just right click, do rename, and replace the white space with an underscore. Maybe aesthetically, that's not the most pleasing thing, but ultimately it's going to get the job done quickly. All right, let's actually look at what we do when we read in a file in Python. We have something that looks quite familiar for the first couple of characters, right? What's going on here? We have f space equals sign. So this is just a variable being defined and being assigned some value, right? That's something we know. F is simply a variable name. We've encountered this before. It could be nearly anything. For files that we read, it's quite common to use F, but that doesn't necessarily restrict you. You can be more creative in whichever way you'd like. So that's the simple part, and then the actually new thing is this open statement. Um, it's a function that takes two arguments here. The second is actually optional, and it will default to what is explicitly written here, but it's a good idea to spell it out here to make it explicit. The first argument is just the file path, and note that this is a string object, right? It just goes within quote marks, and then this is on my work computer. Don't worry about this one. Um, what's important, don't worry about the fact that it's not the same as the previous directory structure in the example. What's important is that it is a directory path. Fortunately, it doesn't have any white space, so that helps. And then the R argument, these are just kind of separated by commas, is it specifies what we want to do with the file that we're opening. In this case, we just want to read it. That means when we open it this way, we avoid the danger of accidentally overwriting or writing to this file. We can only read it, which can be a blessing and a curse, right? I mean, very often this is what we want when we have corpus data. We don't want to change the data itself or overwrite it, but we maybe want to do something with it and then write the results to a separate results file. How to open such a file where we write to, we'll leave that for the next video. One important thing to note is that opening a file is not the same as reading in its content. So this opens a text file, but the file is not fed, the content of the file is not fed into Python. And you can sort of do this with an arbitrary file that doesn't include text in the way you would expect it to be included, that is really long or really short. For that first command, that all of that doesn't matter. What it gives you, if you try it, if you type in the command type F, you'll see it's not a string, what we get. Let me actually show you this here. So I'm opening a file to Shakespeare's Complete Works, which is the same thing you'll be doing in a second. With the statement we just encountered, the path here is just slightly longer, but in principle, whether this is a very short or a long string doesn't change anything. And if we do type F, it's an object of the type text IO wrapper, text input output wrapper. Don't worry about the wrapper bit, but it's text, which is nice. Python already expects text to be the content of this file, and IO is input output. What this really means is Python understands that you pointed it to a file. It's now ready to read this file, and it's ready to process it as text, basically. That's quite a lot, but it's not the text of the file itself, right? It really only sort of means Python is now ready to do something. Before we teach Python or get Python to actually do something, let's catch you all up to speed. Let's all just define our F to work with. So on Ilias, you'll find the file Shakespeare Complete Works, which you can download and then just basically in the way I just showed right now. Sorry, I skipped forgot to skip back over to the slides here. Um, anyway, the exercise is to download this text file and do what you basically just saw, right? Read it in, define it in its open state with the variable f. Again, avoid white spaces in file and directory names if at all possible, and be aware that Mac and Linux use forward slashes in their file paths, and Windows uses a backslash, just to make things slightly more complicated. So define a variable f and assign it to the file for reading with the following code. So here, actually, in the first line, you need f equals. Added to this, and then file path, obviously here is a placeholder. You want your actual file path and a comma here, and then check whether it worked. Don't forget the comma before the R. Oh, that was really sloppy of me to not have it in there. And check whether it worked by simply typing type F, and you should get, as Python's output here, this text IO wrapper object. Pause the video, obviously, and continue watching once you have your F ready. And then we'll do something with it, namely read its content. So the simplest and most frequent way I've come to do this is with a simple for loop, for line in F, print line. Let's do that really quickly. None of this is really new, right? How this for loop works, etc. What's new is that it works with something F, right? That's not itself a string object or a list object, not itself an object of any type we've encountered so far. So let's see. For line in F. By the way, the line bit here is a loop variable and thus can be arbitrarily named. It's called line here because that's what it'll produce. So it's just a human reminder of what's going to happen. And it's just going to cycle through all of the text contents. We're not going to read these, but it prints every line bit by bit, which is not necessarily the default behavior you would expect, right? With strings, if this were like a string object, it would print every character on a line. And if it were a list of words, it would be every word on a new line. Here, basically, the structuring device is the line break. So it prints something up to the next line break and then moves on to print the next thing. That's just the conventional behavior for iterating over F without any additional methods or options. It's going to iterate over individual lines. Just something to be aware, I guess. Now the fun bit. Try doing this several times, and you'll find out why not have me try once again. For line in F, print line. This is the exact same code that just produced all of the output above, and here it produces exactly nothing. That is maybe at first surprising. If we had a list or a string and we repeated that same for loop, we'd get the exact same output, right? Because the underlying thing in F is stable. With our IO wrapper, we don't have a stable content to iterate over, but we have basically Python being pointed to a an address in the computer's memory, and then when it does for line in F, it actually moves along until it arrives at the end of the file. And at the end of the first for loop, it's at the end of the file. And when you introduce another for loop, Python is still at the end of the file, and then just has nothing to iterate over. This is a, a very frequent source for frustration. As you're writing the code, you write a for loop that just worked, and then in the next instance, it doesn't produce anything. Well, that's because of this unstable nature of how Python progresses over an open file. There's fortunately a simple solution. We can simply close and reopen the file. Slightly tedious in working in the shell. The good news is we don't typically need to do that once our code is finished. Typically, we just need one pass over the data. But as we sort of practice, we make little mistakes in our for loop and then quickly want to fix it and do it again. It happens to me all the time as well that I forget to close and reopen and then sort of wonder why nothing is happening. So here, going back to the shell. For now, do f.close and reopen it lazily, cycling back up there for line in f. Let's switch the loop variable just to show you that this is not not of any consequence. What we call this will be the same thing, just cycling through all the lines in the file and printing them. All right, excellent. What if we want the whole text as one big string? We can do that as well. I'm not going to dwell on this very long. This is simply, we don't even need a for loop. We just define a variable called text and assign that the value f.read. So the read method applies to an open file. This is basically, this part is akin to not exactly the same thing, but very like 3 quote marks, copy paste everything in there, close with 3 quote marks, right? We have the one big string. Type text is going to produce string, and I've done this here just to iterate one more time here again. Python, after this operation, is at the end of the file, and without closing and reopening, this text2 is f.read is going to produce a string of length 0. It's not going to find any data to read in as text2 because Python has already gone through the file once, right? So text2 is going to be empty. Once again, you need to close and reopen it. Something to think about is the advantages and disadvantages of reading in a file as one big string versus line by line. Personally, I think in almost all scenarios, the line by line bit is the sensible thing to work with for a number of reasons. But if you think about what we've been doing so far in our exercises in class, there's at least one context where having it all as one big string makes life easier. So I'll leave that as food for thought for you to think about. And if you have any questions, we can talk about that obviously in lecture time. The final bit I want to come back to is there are two very similar surface level similar commands for iterating over the lines in a file that under the hood work massively differently. And thinking about these as separate kind of helps also thinking about how we work with Python in general. So there's for line in F, which we've encountered, which is kind of like a for loop that where the loop variable is just updated, assigned to the next line in the open file. So what it does, it really just kind of Python is at a certain point in memory and then reads on from there. Point on your hard drive reads on from there up until the next line break, does something with the stuff read in, and then reads on, right? The major advantage of this is that the whole file is never read in at once. And sometimes you have pretty huge files to work with, and this method doesn't care how big the file is. It only ever needs one tiny bit to work with at a time, and that makes it a lot more memory efficient. And that's a lesson for a lot of things you'll want to do with the computer, even if it's big, massive things you want to do. Typically want to keep the at the moment task and the at the moment memory use very small, and that helps the code to be very efficient. That's not the same with f.read lines. So f.read lines essentially just produces a list where f.read is just reads in the whole content as one big string. This does the same thing and then splits at every white space. So we first need to read, or Python first reads the whole thing in and then splits it. This is only an advantage really if you want exactly this list to do something with. Then this command just achieves that very, very succinctly. But the obvious disadvantage is this only ever works if you have enough memory to read in the whole file. And in the tasks that I typically work with, and I'm not, a super big data person, I very often run into scenarios where f.read lines is simply not possible because my personal computer can't handle the size of the amount of data that would need to be read into working memory, random access memory. All right, and I've kind of hammered away at this point quite a bit, but I want to dedicate a separate slide to it. ABC, always be closing, right? When you have a file open, that file should be closed, and it should be closed as soon as you're done processing it. So if we have an f is open, f is assigned the value open, some file. As soon as we've done f.read or for line in f, close that f. We'll encounter in the next video actually a way of writing the code that doesn't explicitly require the .close method to be used. That basically leaves you no choice but closing it, because that's part of the code structure, but I'll leave that for the next video. If we need to process a file multiple times, it needs to be closed and reopened every time, and you will run into situations where you forget that, and it'll cause you pain. But knowing that is the potential reason helps you debug the script and also avoid the problem more often than not. And then when writing to a file, this is kind of foreshadowing the next video, it's only when we close the open write file that the write operation is actually completed. If we forget that, there will be things missing from the file that we're writing to, and depending on what you're doing, that can be detrimental to the downstream analysis. So the bottom line is in the headline here: ABC, always be closing. Hope you catch the reference. If not, maybe you want to look it up. Nice little YouTube video. Glengarry, Glen Ross, always be closing. Let's finish this lesson with a bit of practice. You've already read in the first exercise the complete works of William Shakespeare. Now we want to calculate the mean word length in this document. So read in the data that should already be there. Feed the entire file's content into Python as one big string. So here we will use this method because here it's actually easier. And then using methods we already are familiar with, splitting and list comprehensions, create a list of word lengths for the text. So basically the whole of the file just as a list of word lengths. And if you want to be clean in your work, get rid of punctuation in that as well, because trailing punctuation will introduce noise in the calculation. And then in order to calculate the mean word length, you can use sum list, which just sums up all of the integer values in the list and just the length of the list. And these two values should put you in a position to calculate the mean word length. And then assign your results to the variable name Willy mean. As always, you can scroll down in the HTML versions of these slides to get the solution. And that really concludes the lecture for today. As always, we finish with a confusing picture that I don't know what to do with. But here it is. Sometimes a picture leaves an immediate impression. I'm not sure what to do with it, but it has a snake. So here it is. Thanks for tuning in. These are the image credits. If you want to look at the HTML versions of the slides, there's the URL here. You can scan the QR code, and they will also be linked in the description to the video. Hope you tune in for the next one, and goodbye for now.